Hi Frank, my name is Mohammed Zain and welcome to my presentation and demonstration of my second assignment for Internet of Things. In this video I'll be demonstrating the system and I'll be going through some of the code as well. So I'm going to be doing a voiceover of a demonstration of a video I took in class. So let me start the video. This is the circuit shown below. So I have an LED resistor panel and I have a microbit all connected. So this is supposed to act as a thermostat. Let me show you. It's running in Debian in the folder called Mohammed, and this is the output of the characteristics. So chip temperature and potentiometer reading. So potentiometer is set to 0 right now, and I'm going to show you what happens when I increase this potentiometer right here. So if you look at the screen, it's at around 0 right now, and as I increase the value of the potentiometer, the value increases until it gets to the max of the potentiometer, which is 4095. So as you can see now, I've put it to max on the breadboard, and it's showing max value 4095 on the terminal as well. So now I'm going to be turning it down all the way down to 0. As you can see, it's put down to 0 now. And now I'm going to demonstrate the LEDs through the BLE scanner app. So I'm going to search for my microbit, which is called Zane. I'm going to connect to it, and it's discovering the devices. And I'm going to then go into and find my LED characteristic, which is 5003, and I'm going to write to it. So as you can see, all the LEDs are off right now on the breadboard, and I'm going to write, say I'm going to want to turn on two LEDs, and I'm going to write 02 followed by 6 zeros after it. And as soon as I press OK, the two LEDs should turn on. As you can see on the breadboard, two LEDs have turned on. So just for another example, I'm going to write to the LEDs again. I'm going to click byte array and I'm going to turn on, for example, 9 LEDs. If I wanted all LEDs to turn on, I'd write 0A followed by 6 zeros. Now if I press OK for the 9 LEDs, you can see that 9 LEDs have turned on the breadboard. And this is the system working. So as you can see on the screen, I'm going to go through. You can see that you got an LED write, showing that it got an LED write from our system. And now I'm going to go through chip temperature. Chip temperature we're showing 23 degrees, and this is shown from this LED, this microbit. And the reason it's showing 23 degrees is because it's the ambient temperature of the room. The sensor is located underneath the microbit and it's hard to access, so it's only going to be showing the ambient temperature. It can only change when the ambient temperature is changed also. Thank you for watching. So the next thing I'm going to show is the potentiometer increasing the LEDs, turning each one on as the value increases. And this was done by a change in the code, a small change, changing from set bar graph LED, which is taking in the LED value and then changing the specified LEDs. But now it's going to be changed to potentiometer divided by 409.5, which is the potentiometer value divided by the max of its value, which is divided by 10 because there's 10 LEDs. And you can see that right here. Now I'm going to be showing that in action. As you can see, the potentiometer reading is set to minimum, and I'm going to change that now. So the potentiometer is going to be slowly turned up now, and what should happen is that LEDs should turn on as the value of the potentiometer increases. And as you can see, it is turning on right there, just as a function of a thermostat. And now I'm reaching max value and all LEDs should be on now. So as I turn it back down, I'm going to show you what the terminal is showing you, what it should read, and have it at halfway there and half the LEDs are on, and it should be about half of 4095, which it is, around 2000-ish. And now I'm going to quickly turn it back down to 0, and that it should show all the LEDs off and 0 showing on the terminal. there's 0 on the terminal, and there's all the LEDs off. So lastly, I'll be going through the code, which is making all the functionality happen and allowing the demonstration to work properly. So the three main files I'd like to go through are the main.c, the adc.c, and the bargraph.c. These three files are important, as well as every other files, both H and C files, but I feel like these are to highlight the most. So in front of you, you see the main.c file, and you see all the libraries that are included in the main.c file. To start off the code, we have the characteristics. So these are the characteristics that we're going to be using in this system. So we have three main characteristics: the heating characteristics, the potentiometer characteristics, which I'm calling pot, and the LED characteristics. In these characteristics, we can see we are assigning each characteristic a bit number that we are going to be using. So in this one, heating is 0x5001, potentiometer is 5002, and the LED is 5003. In these characteristics, we can also declare if they're read and write characteristics, read only characteristics, or write only characteristics. And after all the characteristics have been declared, we have to define them as well. So in this piece of code, we can define the characteristics. So I am declaring heating as my primary characteristic, and then I'm including my other characteristics such as pot and LED as other declarations for the service. What's also included in the main file are the connecting to the via Bluetooth to the microbit from your phone. So we have a series of callback functions to see if you're reading and writing the characteristics from the BLE in the app, um, and it will be transferred onto the terminal like you saw. And then there's callback functions for when you're writing to the characteristics as well. For example, all these callback functions, and also callback functions to make sure and let the user know that they've been connected to that your device has been connected to the central device. Your microbit is now connected to your phone, and so on. And all these print commands will come out when something is either subscribed or not, or connected or not. So this is the main function of the in the main file, which is the void main. And here we are setting our initial values. So to initialize the temperature sensor, we show that the temperature sensor has been gotten, and then it will display all the temperature readings from here. So chip temperature, as you saw in the terminal when I was in the demonstration, that chip temperature would be displayed as temperature val1, which is updating as the temperature is reading. And which will also be displayed is the potentiometer value. So the ADC function, which I'll be going through later, is here, and that is set as the potentiometer value. So it will print out potentiometer pot equals to potentiometer value, which you saw in the demonstration as well. I also explained that set bar graph is the function used to set the how many LEDs are going to be on, and this will be changed, and this would be set if I wanted to use the potentiometer to change the LEDs. So now moving on to the adc.c, we can see at the end of the code, this is the important function we need. So basically, it reads ADC read digital reads the digital value from the ADC channel, and then ADC begin 0 uses it shows if the acquiring the ADC device fails or not, and then finally the final code read voltage is basically a conversion of the digital value to voltage using the ADC range that you got from before. So on to bargraph.c, you can see we're defining the libraries, and then we're defining the pins. So these are the pins on the microbit that we're going to be using, and then the green ones are the ones that are the digital numbers that we're going to be using as well. So in set bar graph, we have all the GPIO pins, all the pins, pin 2, 3, 4, all these are all connected to LEDs, all set to 0, basically turning off. And then we have the case function in this code, which basically when there is for example, if this pin turns on, the rest of the pin turns on as well. Like you saw, if we put in 2, pin LED 1 and 2 will turn on. Likewise, we have pin 3 turn on, we'll have 3, 2, and 1 turn on as demonstrated. Thank you for listening. I hope you enjoyed the demonstration and the code explanation.